sorry about that, having to break it up into two parts. That was actually, we had to go on to hold, and South was on lockdown. So crazy. All right, but everything's good. So let's do some more stats. So here we left off on this slide, the mean of a discrete random variable. So when analyzing discrete random variables, we'll follow the same strategy we used with quantitative data. We're going to describe the shape, the center, the spread, any outliers, and remember, always talk about the variability going on. Okay, is it less variable? Is it really spread out, more variable? That's always a good thing to do too. All right, so the mean of any discrete random variable is an average of the possible outcomes, with each outcome weighted by its probability. So what you're going to do is you have this table going on. To find the mean, basically you're just going to be multiplying the value times its probability, and this value times its probability, this value times its probability, and then you're going to add all of those up. So this is just some formal notation of what you can do. Remember that big old guy, sigma, means to sum things, so you're just multiplying them all up and adding together. Okay, we can also do this in our graphing calculator. So if you go into the stat and go to the list, so in list 1 and in list 2, put, so kind of like back here, this would be your list 1 and your list 2. So put the values in list 1 and put their probabilities in list 2. Then when you go to find the stat calc one variable statistics here like we did before, we're going to do something a little bit different. So we're going to put, after we hit one variable statistics, do list 1 comma list 2. And if you forget where those lists are, they're right there on your calculator. So you can do second L1 right here for the second one, and then second 2 to get to list 2. When you do that, it's going to give you an output that tells you the mean, the standard deviation for this probability distribution. So it's pretty cool. So let's do this one. Consider this APGAR score again. So here are all the probabilities, and it wants you to find now the mean and the just the mean, sorry, the mean, and then interpret it in context. So see if you can go ahead and find the mean of that. You can do it by hand, or you could put it in the calculator with a list. I don't care. And see what you get. This is what I got. Let me know how you did. Hopefully great. All right, so how would I interpret that? What would the mean mean here? Haha. Okay. So it tells us that the mean APGAR score of a randomly selected newborn is 8.128. So I know that the long-term average here, after lots and lots and lots of babies have been given this score, lots and lots and lots, that the average score, this typical score here, is 8.128. Okay. So here, if you just want to kind of see, if you wanted to work it all out by hand, you could. Or again, you can put it into the list. The standard deviation is going to be much easier to get from the list. So that's why I always like to just put them in my list, because usually you're going to have to get your standard deviation anyway. Okay, so just a little side note. The expected value does not need to be a integer, okay? Because it's a probability, like it's the mean going on here. So it's a typical thing that could happen. Oh, here's a little joke for you. The best way to make this decision is by calculating the expected value of each possible outcome. You multiply. I sense that we're done here. Anyway, I thought that was pretty funny. But yes, expected value, This will show up over and over on the AP test, so make sure you know what that means to do. It's just to find the mean. All right, so let's look at this roulette wheel. On an American roulette wheel, there are 38 slots numbered 1 through 36, plus 0 and double 0. Half of the slots from 1 to 36 are red and the other half are black. Both 0 and double 0 slots are green. Suppose a player places a simple bet of $1 bet on red. If the ball lands on a red slot, the player gets the original dollar back plus an additional dollar. If the ball lands on a different color slot, the player loses the dollar. The casino wins it. So let's define this random variable x equals the net gain from a single dollar bet on red. So here the possible values for x are basically 1 and -1. You're either going to gain a dollar or you're going to lose your dollar. So the corresponding probabilities for a red slot, so let's see, half of the 36. So let's see, he bet on, what did he put it on? He bet on red. Okay, so here if I'm betting on red, then that would be if I gain a dollar, okay? If I win for betting on red. So how many reds are there? Well, half of 36 would be 18. So then what are all the possibilities that I could lose? Well, I could get the other half of 36, which would be 18, plus those two green, 0 and double 0, which would give you a total of 20. So this would be your probability distribution going on. What is the player's long-term expected value? So I'll let you calculate that. So basically you're going to take -1 times 20 over 38 and 1 times 18 over 38. And I got -0.0526. And what does this mean? It tells you in the long run, for each time you play, you're going to lose about 5 cents per roulette spin. So that's over many, many, many spins. So that's the long term. All right, so the standard deviation, we can find that as well. And again, I would do the list that we talked about. I think it's a lot easier. But, and remember, standard deviation squared is the variance. So if we wanted to find the variance, we could take the square of the standard deviation. Okay, so the variance of x here, to find this whole variance, you're going to go find the mean. You're going to take each value minus the mean, square those values, multiply them by the p-values, and add all of that up. But that's the variance. So if I wanted to get the standard deviation, what would I need to do? Take the square root. Or, keep going, or we could put those into the list in our calculator, which I would highly suggest. So I would go put that in list 1, that in list 2, do one variable, statistics, and then do list 1, comma, list 2. And the standard deviation is approximately 1.437. See if you got that. Or you can do it by hand if you just like to do that. But just remember your AP test is timed, so you want to get through things quickly as well. Okay, so what does this mean? Interpret this. It just tells us that basically, on average, babies' APGAR scores will differ from the mean by about 1.4 units. Okay, so like the majority of them will be within 1.4. So if I wanted to do that, what was my mean? My mean, if we remember back a little bit ago, was, sorry, 8.1 128. So basically, I know that if I'm to go out 1 standard deviation and forward, so backwards and forwards 1 standard deviation, about 68%, if we remember that empirical rule, so about 68% of APGAR scores fall within this interval. Okay? So lots of ways to kind of talk about and interpret it, but I always like to do this little empirical rule. It always makes me remember it as well. So again, you could do it by hand, fun, get your value, then take the square root to get your standard deviation, or you can go put it into your calculator. And there's, if you want to read the interpretation of that, but I also like to do that, like how I said, the 68%. All right, try this NHL goal. So in 2010, there were 1,319 games played in the National Hockey League's regular season. Let's see, with what's going on here, if we can find that expected value and then compute and interpret the standard deviation. And you can pause me and see how you do. Okay, I'm going to go ahead and move forward to the next slide. So I got an expected value of 2.851. And I've got the standard deviation of 1.63. So this tells me that about 68% of the time, the goals are going to fall within 1.221 to 4.481. Okay. All right, here's another one. If you want to try it as well, if you're feeling good, you can keep moving on. And I'm going to give you the answers to this, so if you want to pause and try it yourself. And here's what I got for my answers. If you have questions about this, let me know. You guys are doing great. Okay. Yay, an AP question. So I would really like you to see, this is an old AP question, how you would do on this one. So it gives us that probability distribution in a table, and it wants us to calculate the expected value of X, and X here is the number of telephone lines used in the technical support center of a software manufacturer at noon each day. So see how you do. If you want to pause. And then the next one says, using past records, the staff at the Technical Support Center randomly selected 20 days and found that an average of 1.25 telephone lines were in use at noon on those days. The staff proposes to select another random sample of 1,000 days and compute the average number of telephone lines that were used at noon on those days. How do you expect the average from this new sample to compare to that of the first sample? So I'll let you try that one. And then C says the median of a random variable is defined as any value x such that the probability that that x is greater than the expected value is going to be greater than 0.5. And the probability that the x is greater, where is that? The probability that it's also greater, sorry, or the probability that that x is smaller than the expected value is also 0.5. Okay, so for the probability distribution shown in the table above, determine the median of x. And then part D says, in a sentence or two, comment on the relationship between the mean and the median relative to the shape of the distribution. So hopefully you didn't think this one was too bad. Here are going to be the answers. So the first one, you just had to find the expected value, and if you wanted to put that in the list, you can. Okay. So part B, so we expect the average based on 1,000 days to be closer to 1.6 than the first average based on 20 days. Both averages have the same expected value, but the variability for the sample of 1,000 would be smaller. So the more that you're going to, the more data you collect, the smaller the variability. Okay, so to find that median, we want to find, let's see, so if it's greater than 0.5 in both situations, the only one that would do that would be 1. Okay, and then the last one asked, what did it ask again? I just forgot. In a sentence or two, comment on the relationship between the mean and the median relative to the shape of the distribution. So if we found the mean to be 1.6 and the median to be 1, so if the mean is higher than the median, then that means, remember, the mean gets pulled out by the skew more, so I know it's going to be skewed right. Okay, continuous random variables. So if you have a continuous random variables, you're not going to be able to make that probability distribution going on because you have an infinite amount of data. So like where we had those x sub I and p sub i's, we're not going to be able to do that because we would never ever end with an infinite amount. So here we're going to be thinking more of like density curves to find that area between two values. So even though it's continuous, we can find a finite area. Okay. And if you remember, we're going to be doing the normal CDF for that. And that's the start, end, mean, comma, standard deviation. Oh, look, and I wrote it there. Okay. So a continuous random variable x takes on all values in an interval of numbers. The probability distribution of x is described by a density curve. The probability of any event is the area under that density curve. Okay, so if I have continuous, I'm going to be dealing with density curves. If I have discrete, I'm going to be dealing with the probability distributions. Young women's height. All right, define y as the height of a randomly chosen woman. Y is a continuous random variable. Hopefully you guys agree with that because there's an infinite amount of heights. And it tells us the distribution is 64 2.7. When I see this right here, I know this is my mean and this is my standard deviation. It's just a notation way to say that. So what is the probability that a randomly chosen woman has a height between 68 and 70 inches? If this is all you do for me, .0562, you will not get full credit. I don't know how many times I can tell you guys this, but this is not enough work. Calculator speak is not enough work. On the AP test, you could draw a little sketch. Here, I think I have one actually. Let me hit the next slide. So you could draw a little sketch. So the mean here is 64, one standard deviation is 2.7 out, and say I'm going to be finding this probability. But I know online that's really hard to do. So what you can do is say the area under the density curve with a mean of 64 and standard deviation of 2.7 from 68 to 70 is 0.0562. Therefore, the probability that a randomly chosen woman, so the probability that it's between 68 and 70 is 5.6%. Okay? So again, don't just you can get your answer from this. That's great. I love it. Sweet. Okay, it's fast, it's easy. But you have to say more than that to get full credit. Okay. So that is a 6.1 summary. And here are the things we learned about random variables, discrete random variables, continuous random variables. We took the mean of a random variable. We found that expected value, which again means to do the mean. The variance, which leads us to the standard deviation. And we're going to go on to 6.2 next time.